Okay, we're live now. So what you're looking at right now is a portion of the Earth's crust. Okay. What I'm going to do is I'm just going to run the animation so you can see what's going on. So first off, you can see there's a buildup of magma down here in the asthenosphere. And as that magma builds up, it starts to move through the Earth's crust. This is oceanic crust. What do you notice about the oceanic crust? What's that? You see how it's moving? Yeah. Okay. As it moves along, it's going to form a chain of islands. Okay. Did you notice how, like a moment ago, you had 3 islands forming? So what I want you to do this time through is watch this island. Okay, the first one that formed. As you watch it, what do you notice happening to its size? It's getting smaller. So why do you think it's getting smaller? Because of erosion? Yeah, I would go with erosion. So out of these islands, which island is the oldest or was created first? The one on the left or the right? The left one. So this one is oldest. And it's getting smaller because of erosion. So this is all less and smaller due to erosion, right? And what scientists noticed, they noticed this pattern of like islands, like this long chain of islands. Let's say that this crust right here, let's say it wasn't moving. What would form here? Would you have a long chain of islands or not? No. What I mean by a long chain of islands is like you get this series. Okay. If the island, if like the Pacific plate here stopped moving, what would happen is you would just get like one really big island. So one other thing, just to make sure this is clear, as you go from here to there, the age of the islands are getting older. Does that make sense so far? All right. Now, I'm going to back this up and we're going to do some of the vocab together. So if you look at your lab there, what's the first vocab word? Mantle plume. Do you have any idea what a mantle plume might be? Well, a mantle plume. Yes. Okay. So it's just a column of hot rock that rises from inside the Earth. Go ahead and write that down. So what's the next word on your vocab? Hot spot. Now, they don't necessarily say hot spot on here specifically, but a hot spot is a stationary source of magma. A stationary source of magma. Let's go ahead and write that down. All right, what's the next word on there? A seamount. So the feature that you saw in here earlier, after all the islands form, is actually called a seamount. So like this little guy right here is a seamount. How would you describe that? A mountain in the sea? Yeah. See like how it says mount? It's like mountain. It's in the sea. So it's below sea level. It's like a little island that isn't big enough to be above sea level. Seamount. So now go ahead and go to the big graph in your lab. So we're going to flip from the front here. You'll notice that you have a bunch of data. And I apologize because some of the y-axis got cut off. So what I'm going to do is just kind of like let you know. So like this is, you probably realize this, but this is a 10 over here. This is a 20, 30, 40, and 50. And the label for over here is in millions of years. So go ahead and write that down. Millions of years. Got it? Okay. So what you're going to be doing is you're going to be plotting the location versus the age of these different islands on here. For example, we'll start with Hawaii. All right? For Hawaii, the longitude is 155 and then degrees and then 30 minutes west. Wait, what's the 30 minutes talking about? Do you remember that? It's been a while since we've done minutes. So like a degree, we don't typically say like 0.5 of a degree or 0.25. What we do is we use, it's kind of like time. Like with time we don't say, well, it's like 12.5 o'clock. You know what I mean? So for time we would say it's like 12:30. So like you can see that 30 is 30 minutes. How many minutes are in 1 hour? How many minutes are in 1 degree? 60. It's the same. Okay. So when you see 155 and 30 minutes, that's really telling you it's like half a degree, since there's 60 minutes in 1 degree. So let's go ahead and put that down here. So it's 155. 155 is over here. And it's 30 minutes. Which way am I going to go for the 30 minutes? Do I go to the left or the right? Which way is it increasing? To the left. It's kind of weird. They kind of have the graph set up a little bit differently. Notice that like the highest number is over here. So the numbers increase until you get up to here, and then they start going back down again. Okay, as you go from here to there, they go back down. So it's a little bit different. So 155 is here, then 155, 30 is going to be right here. Now the point that we're doing though is 0.5 million years. How much are each one of these lines worth for the y-axis? 2. So this is 2. 1 is right there. 0.5 is going to be like really close to the bottom. So it's going to be like 0.5 is going to be like right there. Okay? You got it? You have to label them? Yeah. Oh yeah. So go ahead and put this as Hawaii. All right. Then you have to do the next one. What's the name of the next one? Yeah, Canoe. Good old Canoe. What's the information for Canoe? Million years, good. And then what's its longitude? 170? East. So one thing I want to point out to you is there's a 170 west here and a 170 east. So which one are we going to use? East. Okay. So when you're plotting a little bit, make sure not to confuse the east and the west. That's a common mistake. So here's 170. I'm going to go up to 170. So how high? 39. 39 is going to be right here. Okay. And make sure I label that Canoe. Now you have a ruler. I don't. What you're going to do is you're going to connect those two. Hey, that's not bad. Okay. What you're going to do from here on out is you're going to plot all the other islands. And what you're going to find is those other islands are really close to this line. What this line is saying is as you go from here to there, what happens to the age? Or as you go from Hawaii to Canoe, as you go towards the west, what happens to the age? It increases. Good. Now, one other thing I want to help you with while we're doing this is for NAHOA. You'll notice that like NAHOA says there's no data provided. But it does give you its longitude line. So I'm going to go back here. Okay. Let's get rid of these. So wait, NAHOA is 162 west. So here's 161, 62. So if I'm down here on the 162, how high up do you think I'm going to go Hoa? Because they don't tell you how old it is. So you get to the line. Good. So you're going to plot Nahoa right there on the line. Now, if Nahoa is on that line, like the way I did it, how old is it? 6 years? So, I don't know, as I go across, is this what you're doing? Eight. Good, because each one goes up by 8. Or, I'm sorry, each one goes up by 2. To give you 8 million years. All right. There's a question about that later on. What questions do you have on this?